talk about exceptions really fast. So you guys are seeing a lot of exceptions, right? Null pointer exceptions. Have you seen other types? Has anybody seen a concurrent modification exception? Here's a question. Have you ever programmed in a language where you use return codes instead of exceptions? Basically, you guys started on C, right?
Yeah.
I think. Okay. Well, a lot of times in C, you return Boolean values or integers that indicate whether the function succeeded or failed. Is this a good practice or a bad practice? Let me put it this way. Is it a good design or a bad language design? It's an older language design, and it's not necessarily bad because it's better than nothing, right? I mean, silently swallowing your errors is the worst thing you can do. At least having a return code tells you whether or not the function succeeded. Exceptions are a little different than return codes. How do they differ? With return codes, you return a true or a false, and the caller is free to ignore the return value, right? How often when you're coding do you actually check your return values? Let's just face it, we all assume that the APIs we call always work, right? When you call a function, you just assume it's going to work. And because of that, well, if you were to write proper C code before exceptions came around, every function you write is going to have to look kind of like this. If do something, no, if not do something, then handle the problem. If not do the next thing, handle the problem. If not, step 3, handle the problem. And basically, well-written C code looks like this, and it's a big pain, and basically most people omit the if statements, and they just do something all the time and hope it works. And what happens when the code doesn't? When this API fails? For example, if do something is load a file from disk and that file doesn't exist, what happens? Well, your program gets into a bad state. What happens when your program's in a bad state? Bad stuff happens, bugs that are hard to find, badness. So the whole point of exceptions is we don't want the programmer to have to write code like this. We want the programmer to just write do something, do the next thing, and do step 3. And whoa, something just became messy. And I better put semicolons here. That code is so much easier to read, isn't it? Plus, more importantly, this is the way programmers write. Well, kind of like how Nintendo noticed that users are mashing really hard on the buttons. I'm a little OCD, and so I just get really bothered by that. People push really hard on the buttons, and I always want to say to them, it doesn't jump higher when you push harder on the buttons. And then Nintendo came along and made it so that they do. And that really bothered me. And then people started playing like this. They're playing Mario, and they want to go left, and they go, whoa! And then they go, whoa, with their paddles. And I would always yell at them, it doesn't affect things when you swing your paddle left. And guess what they did? The new paddles, you move them around, and they respond to that. It made me so mad. And I have a laptop computer, and people are pointing things out to me, and they're like, right here. And they touch my screen, and I'm like, you can't touch the screen. And guess what technology did? Now everything has touch screens. The thing is, users will never learn. You have to adapt to them, apparently. Now we have touchscreen computers and paddles that respond when you play like this while you're playing your video games. And I guess it's the way things work. Well, this is the way people want to program. And so it turns out the programming language should make this be the correct behavior. And with exceptions, it is. Because if anything goes wrong inside of, say, do something, it's never going to call do the next thing. Why? Because this will throw an exception. And what does an exception do? It unwinds the stack. Do you remember what a call stack is? Well, function A called function B, which called function C, which called this function. And so as soon as an exception occurs, well, it just unwinds the stack, which means it does pop, 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 pop. Everything on the stack just gets blown away. And this function is not even on the stack anymore. And it's in the function that called that function. And that gets blown away until it reaches a catch block. When it finally reaches a catch block, then it stops unwinding the stack, and then it handles the problem. So exception E. This is what a try catch block looks like. There's one other thing you can do here. You can put a finally. Has anybody seen that before? Okay. A finally means do what's in this block if an exception is thrown, and do what's in this block if an exception is not thrown. So try, it will try to do it, and maybe it will succeed and maybe it will not. Catch, this stuff will happen if and only if a problem occurs. The stuff in here is how you handle the exception, the exceptional thing. And finally is something that you want to have happen absolutely no matter what. So for example, if you're going to say file f equals open file some file.txt or some filth.txt if you prefer, you may want to close the file, right? Because files should be closed. That's the kind of thing you usually put in a finally block, because even if something wrong happens in here, like if here you were reading a bit, read something, whether or not this read succeeded, you want to eventually close the file. Now, as it happens, this doesn't even make sense because this f has a scope between here, and so this f won't compile. So maybe this line actually belonged up here, and lots of other stuff. The point I'm trying to get across to you is, hey, try is a block where it tries stuff. Catch is a block that happens only if an error occurs. Finally is a block that happens no matter what. Do you remember I said never use catch in your code? You really should never use catch in your code, because really that means hide the error. Unless in here you have something like that, which means terminate my entire program, and e.print stack trace. In which case it is actually going to do some printing. Yes?
So why do we use finally? Why we don't just put that close up just now?
Why not just put it here? Because if an exception occurs in here, well, it depends what you have inside of catch. Something you can do, you can actually throw the exception again inside of a catch block. And that's not a bad thing to do. This will give you the chance to deal with it, maybe log that something bad happened, and then rethrow the exception. If you do that, then this is going to start unwinding the stack. But that means this code will never get called, but this code will, because finally gets called even while it's unwinding the stack. Here's another case. You can often have finally blocks with no catch if you want, and it might be that an exception is thrown inside one of these functions that's inside this try block, and finally we'll allow it to, let's see, println stuff. In this case, f.close will be called. Stuff will not be called if an exception occurs in read. Does that make sense? So the whole point of finally is just to guarantee that something's going to get called even if bad stuff happens. In general, exceptions are supposed to be exceptional. There are things that don't usually happen, so you can code as if they'll never happen. In my opinion, you should try to use try as little as possible, but you should throw exceptions all the time. And I think I've already emphasized that. But throw exceptions whenever you possibly can, write self-debugging code, check all your conditions, and then you'll have much less debugging to do in the long run. Okay, do you understand the concept of unwinding the stack? Okay, well, I'll post example midterms in the near future as we're preparing for our midterm. One question I like to ask is, here's some example code. This function calls that function, this function calls that function throws an exception, and there's code all over, and your job is to tell me what this code does, or what it prints to the screen, or something like that. And you have to be able to understand which paths the code actually follows. This kind of shows if you understand the Java code. So make sure you understand what a try, catch, and finally block do, because I'm trying to express that. Okay. Here's something I need to show you. Oh yeah, and that. Haha. That's getting pushed onto my queue. Then I'll come back to it. Anybody notice this? I stuck a thing here called the automated professor. Okay. Obviously, this is not a substitute for me, but, well, I'm trying to make it one. The idea is, every time someone asks me a question, I ask myself, could the automated professor have handled that? And if not, I go update it. And after enough iterations of this, I should get to the point where I can finally just put my feet up on my desk, and this will handle everybody's problems, and I will have automated away my job. That's what computer programmers try to do. We never succeed, but we try until the day we die, trying to automate everything. And so that's what I've done. Let's suppose you need help finding a bug. Well, do you know exactly what you want your code to do? Well, I know what results I want. Computers are not magical wish-granting devices. They are instruction-following machines. These are conversations that happen quite a bit. And so maybe if you have a question and I'm not available, you could try this thing, see if it works. But if you find that it doesn't answer a question you have, I'd really like to know exactly how far it takes you and where you got to and what it didn't answer. And then maybe I can update it and save a lot of time in the future. Okay. That's a question we get a lot, obviously. Yes, I don't understand why my code isn't working. Okay. Do you know the point where your program first deviates from the expected behavior? Do you know what this question is asking? Okay, this is a thing that I get a lot. People say, hey, I wrote my code, but it doesn't work. What's wrong? Well, what did you want it to, what does it do and what did you want it to do, right? They must have been the same to a certain amount of time and then they diverged at some point and then it stopped doing what you wanted. You have to know when the difference occurred. Well, can you identify a variable that has an incorrect value at that point? Yes, I can, or how do I determine the values at that point? Well, the answer is to print them out. Do you see how this basically answers a lot of the debugging questions that you have? If you want to, I think it would be useful for you to plow around through this and navigate some of the Q&As. Here's why. It kind of teaches you how to debug code. So if you're having trouble debugging, well, spending a little time with this would insult you until you no longer have problems with debugging. What I'm saying is, yes, I understand that getting help from an automated thing is just really awful. You ever call those phone services and they say, if you want to talk to a real person, say real person. And if you want to, oh, I get so mad at those. I don't like talking to machines. I don't know why that is, but I usually say something really vulgar into the phone, just hoping that that'll get me a real person instead of their dumb menus. Yeah, this isn't going to be super helpful, but it is designed to show you the basic process of debugging. And here's where that basic process is. You need to know what you're looking for, and then we start looking at the variables. There's always a value. There's always something in the code that's not right, isn't there? By definition. If all of your variables have the correct values, well, that's what code is, then your program works correctly. Therefore, there's always a value somewhere that isn't right, and you don't know which value it is. Am I right about that? So how are you going to know which value it is? Well, you're going to go to the point where at least you know it's gone wrong, and then try to figure out what the values are then, and then figure out how they got there, and back up a little bit until you've nailed down exactly when the first value took on the first wrong value, and the first variable took on the first wrong value, and then you've nailed the bug. That's how we debug stuff. Only way to do it is to print lots of things, to look at your code, to know what's going on. Debuggers are really helpful for that. But in the end, it comes down to this. Understand what's going on, understand how that differs from what you want. There's the bug. Fix it. Does that make sense? Okay. You guys familiar with binary search? Okay, great. We used it in assignment 2, I think, to find the starting tube thing. That was a good idea at the time, I thought. The idea was it would make the code all super efficient. Here's the thing with that. In the end, this whole game is going to involve only this much map anyway, because we're not writing Mario. We're just writing a little demo game to prove that you can master a few concepts. So if you want to just run through and print all the tubes instead of just the few efficient ones, that's good enough for this assignment. We've already gone past the stage where it has to be efficient. So somebody asked me, if I add my fireballs to the to the list of sprites, where should that be sorted in the order? I don't remember who asked me that, and I don't remember answering the question, so I'm not sure I did. Here's the short answer to that. For right now, let's not worry about it. Just run through the whole list, and we'll not worry about efficiency. What if we really did want to make it efficient? How would we do that? Yeah, that would work. You could have two lists if you want. Here's a list of things that are transient, that are coming and going from the list, and then another list of things that are going to be there all the time. And then that big list of things that are going to be there all the time should be sorted so you can do it efficiently, then plus all the fireballs list. Tag it like you said. There's any number of ways you could solve this problem. There's no right answer. When you write code, the only thing that's wrong is to not know what's going on. If you have control of your code and you're making it do what you want, you're doing it right.